If percentage questions keep tripping you up, it's not because you're bad at maths. It's because you don't have a system. So I'm going to show you 3 tools to go from confused to competent when it comes to percentage questions. My name's Farhan, I'm a junior doctor, and I've helped over 100 students get into medicine and dentistry across Australia. And today, you're going to learn how to answer percentage questions easily through knowing how to convert percentages to decimals, knowing how to use the unitary method, and going through the percentage change formula as well. So let's go through percentages as decimals. What you want to be doing is converting every single percentage you come across into a decimal when it comes to calculations, because it means your calculations become faster because there's less inputs, but with less inputs also means there's a lower likelihood of making errors because you have to put less numbers into the calculator. And we all know how tough and difficult the calculator is to use. So what I want you to do is relate every percentage to the number 100%. And therefore, relate every decimal to 1.00. For example, 80% becomes 0.8 and 130% becomes 1.3. So if I am tasking you to find 87% of the number 43, then you're not going to do this, where you go 43 divided by 100 times 87. You're just going to go 43 times 0.87, because that's the fastest way to do it. Now, let's go into the unitary method. So we're going to begin with this question. I want you to pause the video and try and get this question as quickly as you can. So now that you've had a go at this question, let's break down in excruciating detail how to actually go about a question like this so that we can understand how to go about it quickly. So first of all, what is this question asking? It's asking you, what is 100% of the value? That's what it means by full value. So now we have to ask ourselves, how do we find 100%? Well, to find 100%, the easiest way is to find 1% first. And this is the unitary method, breaking things down into the simplest unit, which is usually 1%, so that you can find basically anything else. So how do we find this 1%? Well, we have the numbers in front of us. 29,600 is 37%. So we divide 29,600 by 37, we get 1%, which ends up being 800. So now that we have 1%, we can find any percent, 45%, 37%, 89%. We can also find 100%. And the way we do that is multiply that 1% by 100. And we end up getting $80,000. So the goal here with the unitary method is to get so quick that we can condense that entire thought process into one single calculator step. Now you might be asking, one step? How on earth do we do that? So I'm going to show you exactly how we do that. So here's what we did, right? We got 29,600 and we divided it by 37 and then multiplied by 100. That's essentially what we did. So I'm going to rewrite that times 100 over 37. Now I'm going to rewrite that as 29,600 divided by 37 over 100. All I'm doing is expressing the same thing in just a different format. And all I've done here is literally just flip the fraction around and change the sign. This is year 4 maths now. So would you agree with me that this is the same as dividing by this number? And so if you pull up the calculator, you put in 29,600 divided by 0.37, you are going to get the answer of $80,000. So this is how you can get scary quick when it comes to percentage questions. So here are just a couple of work examples to put that into practice. So feel free to have a go at this, pause the video, and then we'll go through it together. All right, so now that you've had a go at this question, let's run through it together. So the number of specimens in Museum A is 30% of the number of specimens in Museum B. Cool, can't do much with that. Number of specimens in C is 60% of that in Museum A. Still can't do much with that information. If the specimen collection in Museum C is 450, then what is the specimen collection in Museum B? So we know that we're working towards Museum B, and our really only piece of concrete information is here. Museum C is 450. So we're going to have to work backwards. So we know that C is 450 and Museum C is 60% of that in Museum A. So here we can begin to use the unitary method really quickly. So if we want to find A, which is going to be 100%, and we know C is 60%, then the way we do that is we get the number in C, we divide that by 0.6, we end up getting the number 750. Next, we know that this is the number of specimens in Museum A, and that is only 30% of what's in Museum B, which is what we're working towards. So now if we want to find B, we just get this number, we divide this by 0.3, and we end up getting 100%, which is B, 2500. So C ends up being our answer in this. With this one-step unitary method process, a question like this goes from taking us maybe 30 seconds to do, or maybe even 40 seconds to do, to being razor quick, like basically like 15 seconds tops. So here is how you can really save a lot of time. Let's go into another question now. So feel free to have a go at the question and then we'll go through it together. Cool. Okay, so let's run through this one now. It's a very similar concept. We know if sample C, so now we're looking at C, contains 50.4 grams of mica, which is 12%, then what's the total weight of sample C? What does total weight mean? It means we're trying to find 100%. What do we have? We've got 12%, which is 50.4. So what do? We end up getting 50.4 divided by 0.12, which gives us our answer of C, 420 grams. Perfect. Basically a one-step solution to this question. Now, let's go through a couple more general percentage questions that might test your understanding a bit more. Starting off with this one. Feel free to pause the video now and have a go. Alrighty, so let's run through this question together. So, we know that we're basically looking for the percentage of Ethiopian beans in the resulting blend. So, what does that mean? We want the percentage of Ethiopian beans in the total. These are the two numbers that we need to figure out. So what's the total to begin with? Well, we know 180 plus 270 gives us a total of 450 grams. Now, we just need to figure out how many grams of Ethiopian beans are in there. So if there's 180 grams of Morning Glory, and we know 50% of those beans are Ethiopian, then we can end up going 180 times 0.5, which gives us 90 grams of Ethiopian beans from Morning Glory. And next, we have 270 grams of dark roast. So we've got 270 grams. What's the percentage? 20%. So times 0.2, that ends up giving us 54 grams from the dark roast. We add these two together and we get our answer of 144 grams. So 144 divided by 450, if you pop that into the calculator, ends up giving you 32% as your answer. So hopefully you can see the thinking process behind this. There's no one trick to find the answer really quickly here, but what you can do to help economize the process to help make it quicker to actually answer this question is, first of all, realize what you need to find, the total, and then the percentage of the amount of Ethiopian beans, so that you can find the percentage. And then really making your life easy by making percentages as decimals so that you can make these calculations really quick. And we've got one more question for the percentages section here. So feel free to have a go at this and then we'll go through it together. All right, so let's go through this one together now. So the percentage of spending on medical equipment and supplies in 2022/23 was to the nearest whole percentage. So what do we need again? We need the amount spent in medical equipment in 22/23 versus the total of 22/23. What do we have in front of us? Well, we've got the budget, but only for 23/24. So we're going to need to use all the information that we have in front of us to find the budget in 22/23. So we've got the total budget here, and this column here is basically telling us by how much did this number increase as compared to the last year. So if we subtract all of these numbers from this total budget, we end up getting our number of 534. Now, we've got 112 here, and we know that that was an increase of 5 from last year. So what we do is we subtract 5 from 112, we get 107. We run this through the calculator, we end up getting around about 20%. So once again, our answer ends up being B here of 20%. Now, if you found the unitary method helpful, that's just one of the many frameworks that I have for the UCAT. So if you want all my frameworks for the UCAT in one place, then just click the first link in the description below. Now, let's move on to percentage change. So it's a question type that is actually very incredibly common, but it's an extension of percentages. The reason I say this is because you need to be comfortable with your concept of percentages and what it actually means at a mathematical level so that you can actually do these percentage change questions and not doubt yourself. Now, when it comes to these questions, there are three variables: original value, new value, and percentage change. And questions usually provide two variables and require you to solve the third. Now, when it comes to finding the original value or the new value, we use the same principles that we just went through for the unitary method. Nothing changes. But when it comes to finding the percentage change itself, this can be a bit of a trickier situation. And so this is where this particular formula comes in, where percentage change equals the new value minus the old value divided by the old value. If you remember this, you cannot go wrong. Now, another thing to note though is what sort of output are you getting from the calculator? You end up getting a decimal output, but you need to know how to interpret it. For example, if you end up getting an answer of 0.45, what your calculator is actually trying to tell you is that there was a positive 45% change. If you end up getting 1.23, you end up getting 123% change. You can also get a negative output here as well. If you get a negative 0.32, that means you have a minus 32% change. So let's think about it, right? If you have the new value being 50, the old value was 80, and you have the old value 80 here, that's negative 30 on 80. It's telling you it went from a higher number to a lower number. That's a negative change when it comes to percentages. So just beware and know how to interpret the output that the calculator is giving you. So let's go through some worked examples of percentage change questions. So feel free to pause the video now and have a go at this question. Fantastic. So hopefully you've had a chance to go through this question now and you've realized that this is basically a plug and play of the formula that we just went through. So we have our old value here, what we started with. We've got our new value here, what we're going to end up with. So we just plug in the numbers. 31,200 minus 7,800 divided by 7,800. You end up getting the output of 3, which actually means that the percentage change ends up being 300%. Fantastic. Good stuff. Now, let's move on to the next question. Feel free to pause the video now and have a go. All right, so let's go through this together now. So the way I like to go through these questions is to think, well, what's the new value going to be? So if there's a decrease by 45% next year, or in this year compared to last year, all right, in the following year, right? If there's going to be a decrease by 45%, what that actually means is that next year is going to look like 100 minus 45, which leaves you with 55. So it's going to be 55% of whatever is here. Simple. 55 gives us our answer of C, 17,160 in this case. Lovely. Let's move on. Pause the video now and have a go. Okay, let's go through this. So hopefully you've recognized it's actually very similar to the previous question. So if there's going to be an 18% increase from last year's profit, then what that looks like is 1.18 as your multiple. So 31,200 times 1.18. So if you think about it, that's actually telling you it's going to be 118% of whatever it was last year. So that ends up giving you our answer of E. And here's our last question for this lot. So feel free to pause the video now and have a go at this one. All right, so let's go through this question now. Now, if you got the answer of 18,420 and you were realizing, that's not one of these options, I want you to virtually raise your hand up, because what you've just done there is made one of the most common mistakes when it comes to percentage change questions. So if you landed on this answer, then what you've done is you've thought, okay, well, if this number is exactly 25% more than what we're trying to find, right? Let me visually point this out. So if this number, 24,560, is exactly 25% more than what number we're trying to find here, and 100 minus 25 is equal to 75, then what I'm going to do is go 24,560 times 0.75. And that gives you this answer. Now, I'm going to show you why this is the incorrect answer. But before I do that, I'm going to show you how to actually go about this the correct way, just so I can show you side by side. So how I actually want you to think about it is, well, if last year was 100% and we know this year is exactly 25% more, then we're at 125% at the moment. 125% is $24,560. And if we're trying to find 100%, then what do? We divide it by 125%. So 24,560 divided by 1.25 ends up giving us our answer of A in this case. But now let's explain the difference. Like, how did this get our answer of A, whereas the other thing didn't? When we went from 75% to 100%. The same thing. Well, on the surface of things, it looks like the same thing because the absolute number between 100 and 125 is 25. And the number between 75 and 100% is 25. But the percentage change between them is not the same. Okay, let's have a look. So if we have 100 and we're going from 100 to 125, then let's use the percentage change formula. New value, 125. Old value, 100, divided by 100. What does that give us? That literally gives us 25%. So this way, we know that this is actually a 25% change. Whereas, if we go from 75% to 100, let's see what that gives us. 100 minus 75, divided by 75. And if we go 100 minus 75, that's 25. Divided by 75, 1/3, that's 33%. So when we multiply this number by 0.75 to try and find what it was last year, if you ended up having 18,420 as your answer, what we're actually doing there is we're saying that there was a 33% change from one year to another, when actually what we want is a 25% change from one year to the other. So I always like to think of the base of 100. So hopefully this example illustrates the difference between why you should never treat 75 to 100 the same way as you do 100 to 125. And different cases need different approaches. Let's go through a couple more questions just to drive home the concept of percentage change, starting off with this one. So feel free to pause the video here and have a go. Okay, so let's go through this together now. So between 2014 and 2023, it's literally telling you old value, new value. What's the percentage drop? So we've got 370 and 680 as our numbers of choice. So what's the new value? 370. Old, 680. Old, 680. You end up getting the number of negative 0.455. That's what the calculator tells you. So we know that this is a negative change and it's a percentage drop. So we're heading in the right direction here. And 45.5 rounded ends up being 46. More questions. So feel free to pause the video here and have a go. All right, so let's go through this one together. So hopefully you recognize that what we needed to do is add up the migratory and resident bird species together. So if you add these up, you end up getting 5,180. And if you add these up, you end up getting an exact number of 5,000. So now that we have these numbers, then we can use the percentage change formula to find what we want. Now, the only place you can really go wrong here is picking the wrong new value and the wrong old value. So the way we do that is we read the question and ask ourselves, or see for ourselves, what's the comparison and what's the comparator? So approximately by what percentage is the migratory bird species greater than the number of resident bird species? So you see how when it says when greater than the number of resident bird species, it's saying if we have the residents as the baseline here, by what percentage is the migratory bigger? So because the residence is painted out to be our baseline in this case, then we have that as our old value, whereas this one ends up being our new value. So we end up getting 5,180 minus 5,000 divided by 5,000, which gives you our perfect answer of 0.036. That is our answer of B. Now, by the way, in case you have trouble interpreting whatever's in this calculator, you can just multiply it by 100 to give you the percentage answer. So you multiply this by 100, you end up getting 3.6 in the calculator, which is exactly what you see in front of you. So if you want to be risk averse and you don't want to leave the interpretation up to chance, then just multiply by 100. Because sometimes you're going to have a 0.00058 in there, and your answer options are going to be 0.058%, and then 5.8%, and then 0.58%. So just multiply by 100, and then pick what you see. Now, that was just a handful of questions that we've gone through. And if you want to do more practice questions and you don't already have a question platform, then you can use the code Farhan for 10% off MedEntry. Otherwise, here are just a couple of traps that students fall into when it comes to percentage questions. Number one is treating an increase of 25% as 0.25 instead of 1.25%. Remember, we're going from 100 to 125% if we're increasing like that. So don't put 0.25, otherwise you're going to need to do another additional calculation of just adding the original value in there. Next is treating 75% to 100% as the same as 100% to 125%. We've just gone through the maths behind why this is a 33% change and why this is a true 25% change. What matters is what the baseline number is. So it's 75% here and 100% here. And actually, mathematically, that changes your old value. And lastly is mixing up the new value and the old value when it comes to plugging it into the formula. So here are your do's and don'ts. First of all, do rewrite every percentage around the number 1.00 before calculating. Do utilize the unitary method and do use the percentage change formula. Don't complicate the flow by unnecessarily using the calculator memory functions if you don't need to. Don't treat 75% to 100% as the same as 100% to 125%. And don't mix a really silly place to lose marks. So here are your next steps. For your next 20 percentage questions that you do, I want you to consciously apply the three strategies: percentages as decimals, the unitary method, and percentage change formula, and see how much faster you get and how much more accurate you get.